Number 15. Suppose the demand for a certain item is given by D of P equals negative 4P squared minus 5P plus 300, where P represents the price of the item in dollars. Find the rate of change of demand with respect to price and interpret the rate of change of demand. Now you'll notice they do not say the average rate of change. So what they're talking about here is the instantaneous rate of change, or the derivative. Now in number 14, I started to introduce you to a few shortcuts for taking derivatives. And here was those shortcuts. If f of x, or any part of f of x, is c, a number, then the derivative of any number is 0. Because how does a constant number change? It doesn't change. Then we said, if part of a function is c times x, then the derivative of that function is just going to be c, which is the slope of a line, and cx represents a line. So when you have a constant, its derivative is 0, and when you have a constant times an x to the 1, that constant is going to be the derivative. Now in this case, we have a higher exponent. We have a p to the 2. So if I've got f of x equals x to the p power, then the derivative of that, without going through the difference quotient limit as h goes to 0, it's going to be p times x to the p minus 1. If it happens to be a function with a number in front of a power higher than 1, like cx to the p, my derivative is going to be c times p x to the p minus 1. So these are the derivative shortcuts that are nice to know. That if it's a constant, the derivative is 0. If it's a constant times x to the first, the coefficient or the constant is the derivative. If it's a variable to a power, it's the power to the variable to the power minus 1. And if there happens to be a constant in front of that variable to a power, it's the constant times the exponent times the base x to the power minus 1. So we're going to use this to help us do this one much more quickly. So here's our function. D of p equals negative 4p squared minus 5p plus 300. Now remember, we could do the difference quotient on this. The limit as h goes to 0 of f of x plus h minus f of x over h, and that would give us a formula for d prime of p. But now that we know that there are some shortcuts, we'll do the shortcuts. And I'm going to start over here at the 300 because that's the easiest. When you have a constant, the derivative is 0. When you have a constant times a variable to the first power, the coefficient is the derivative. And when you have a base to a power with a constant, it's the constant times the power, and then the base to the power minus 1. So cleaning this up, negative 8p to the 1 minus 5. So look how much shorter that process is than doing minus 4p plus h squared minus 5p plus h plus, and then having to evaluate that and then subtract out the original 4p squared minus 5p plus 300. Change these signs. See how much faster this is. This is much faster than doing the difference quotient. Now, it's important to know the difference quotient because that's an explanation of why the derivative exists. If you've watched earlier videos, I spoke to you about how when you have 2 points on a curve and you draw a line through that, you get a secant. But if you have only 1 point, you get a tangent. And how you get that, if this is x, and the difference between these two is h, this is x plus h. If you move this point, this second point, back toward the first point, you'll get your tangent line, and that's where this limit comes from. The shortcut can be used unless the directions say using the definition of the derivative. Okay, you got to use the definition if you're instructed to do so. Now we have a formula for the rate of change. Okay, this is instantaneous rate of change, but now we just call it the rate of change, and we know that that means instantaneous. Okay, and so we can answer the questions that they ask us to do by using this formula. So we got our rate of change, negative 8p minus 5. And so now we can do some substitution in here. And we can find it at, when the price is, let's see, $10. So that would be f prime of 10, which would be negative 8 times 10 minus 5 is negative 80 minus 5 is minus 85. Now remember, this is the price, and this is how the items are changing. And this time it's going down or decreasing by 85 items at the price of $10. So let's see, when the price is $10, so all of these say price is $10, so that's correct. Okay. The demand is increasing. No, it's not increasing. Okay. So it's decreasing, but is it at the increase in price of $1 or increase in price of $10? Well, this is not an increase in the price of $10. This is a price of $10. So the interpretation is when the price is $10, the demand is decreasing at about a rate of 85 items. Now we don't need to put the minus because this decreasing takes care of the minus. So it's going down by 85 for each increase in price of $1. Why is that? Because it's minus 85 over 1.